We continue day 1 with more factoring and solving quadratic equations. In example 5, we have 3x squared plus 5x minus 12. The first thing we want to do is check for the GCF. Notice that there is not a number that we could take out of all three terms. Look for difference of two squares, and again, this is not a difference of two squares. So target product, target sum. The target product is 36. Target sum is 5. So the two numbers that will multiply together to give me 36 but combine to give me 5 are 9 and negative 4. So this is what I'm going to replace 5x with. 9x and minus 4x. Now we factor by grouping. I'm going to group the first two terms together, put a plus sign in between them, and group the second terms together. This is an important note. Whenever the first term in any of your grouping is negative, pull out the negative. In the first term, I could pull out a 3 and an x. This leaves us with x plus 3. In the second term, we can pull out a negative 4, and this leaves us also with x plus 3. The two parts that are the same is one of our factors, and what's left over is our other factor. Remember, we multiply these together because we're looking at factors, and this is our answer. Example 6. 2x squared plus 9x minus 18. First, we want to take out the greatest common factor if possible. We can see that there are no factors in common. Is this a difference of two squares? And it is not. The target product is negative 36. The target sum is 9. The two numbers that multiply together to get negative 36 but combine to get 9 are 12 and negative 3. So I'm going to replace 9x with 12 and negative 3. Now we group them. Now remember, any time that there's a negative in front, we want to pull that out. The greatest common factor is 2x. That leaves me with x plus 6. In the second term, I can pull out a negative 3, and that leaves me with x plus 6. These two, x plus 6, are the same, so that is one of the factors. The other factor is 2x minus 3. In example 7, we have 4x squared minus 12x plus 9. Again, we want to pull out the GCF if possible, but there is not a GCF for me to pull out in all three terms. I want to check and see if there are a difference of two squares. That is not. The next thing I want to check before I do target product, target sum is if it's a perfect square trinomial. It's not necessary that I know perfect square trinomial formula. However, the format, if I recognize it, it can save me some time and work. So what I look for is the first and last term. Can I take a perfect square root of these terms? Well, the square root of 4x squared is 2x. The square root of 9 is 3. The next thing I look for is if I multiply 2 times these terms, do I get the middle term back? And 2 times 4 times 3 is 12x. So this falls in the form, going back to our notes, that if this is a perfect square root and b squared is a perfect square root, then it's just a plus b squared. And if the sign in the middle is a negative, then it would be an a minus b squared. The sign in here is negative, so this would be an a minus b squared. So the answer is a, which is 2x, minus 3 squared. Let's just say I don't recognize it for some reason or other. Instead, what I want to do is target product, target sum. The target product is 36. The target sum is negative 12. The two factors that would give me 36 and negative 12, negative 6 and negative 6. So this is what I'm going to replace negative 12x with. Now that I've replaced them, I'm going to group these terms together. Now we take out the GCF of each binomial, the first GCF, in the first parentheses, I could pull out a 2x. This leaves me with 2x plus 2x minus 3. In the second parentheses, I could pull out a negative 3, and this also leaves me with 2x minus 3. These two terms are the same, and that becomes one of my factors. The other factor is what is left over, which is also 2x minus 3. So the answer is 2x minus 3 squared. So it does not matter how you come up with it. It's just if you recognize this pattern, it just makes it a whole lot less work. The next part of today's lesson is to solve an equation by factoring. We do that by getting 0 to one side, factor, and then set each factor equal to 0 and solve separately. So the first one I want to solve for is x squared is equal to x plus 30. To begin, we want to solve with x squared being positive. So I want to bring these two numbers to the other side. So we have x squared minus x minus 30 is equal to 0. Now that they're set equal to 0, we need to factor. The target product is 1 times negative 30, which is negative 30. The target sum is negative 1. So this is going to be negative 6 plus 5. Now it's a good thing to note at this point that if the coefficient in front of x squared is 1, then I can just set them inside their factors without grouping. So this would be x minus 6, x plus 5. Now we need to set each of these equal to 0. X minus 6 equals 0, and x plus 5 equals 0. So one of the answers is x equals 6. The other answer is x equals negative 5. To check these answers to verify that this is true, just plug each one individually into the problem. The first one, 6 squared, is equal to 6 plus 30. Is that true? Well, 36 is equal to 36, so this is true. Plug in the second value to see if that is true. Negative 5 squared, is that equal to negative 5 plus 30? Well, 25 is equal to 25, so this is also true. Number 2, x squared minus 2x is equal to 0. To begin, remember we need to pull out our GCF, and the GCF in this problem is an x. So when I pull out x, that leaves just x times x minus 2. Remember, we have to set this equal to 0. Then we set each factor to 0. So x is a factor, so we set it to 0. And x minus 2 is also a factor. Now we solve each for x. This one's already done. And then this is x is equal to, when I bring 2 to the other side, it's equal to positive 2. We check our answer the same way we do in number 1 to verify. Number 3, 3x squared minus 8 equals 10x. To begin, we need to set this equal to 0. So therefore I need to move 10x to the other side. When I do that, it becomes negative 10x. Now we need to factor. Always check to see if there is a GCF, and in this case there is not a GCF. After GCF, we need to check to see if it's a difference of two squares, and it's not. Then we need to also check to see if it's a perfect square trinomial. I cannot take the perfect square root of 3 or 8. It ends up being a decimal number, so I do not have a perfect square trinomial. So now I can go to target product, target sum. The target product is 3 times negative 8, which is negative 24. The target sum is negative 10. The two numbers that multiply together to give me negative 24 but combine to give me negative 10 are negative 12 and positive 2. So this is what I'm going to replace negative 10. 3x squared minus 12x plus 2x minus 8 equals 0. Now let's group these together. 3x squared minus 12x plus 2x minus 8 in the second group. In the first problem, I could pull out a 3x, and that leaves me with x minus 4. In the second problem, I could pull out a positive 2, and that leaves me with x minus 4. So both of these have an x minus 4 in common, both of these terms. What's left over is a 3x plus 2. Now we need to set each factor equal to 0 so that we can solve. In the first term, x minus 4 is equal to 0, so x is equal to 4. And 3x plus 2 is equal to 0. 3x is equal to negative 2, so x equals to negative 2/3. Again, when we check both of these answers, these both hold true. Example 4. 8x plus 24 equals to 2x squared. This time, we need to bring both of these over to the right-hand side because we want x squared to be positive. Set it equal to 0. We have 2x squared minus 8x minus 24. Pull out the greatest common factor, and the GCF is 2. This is not a difference of squares, so I can't use that. This is not a perfect square trinomial, so I cannot use that. However, I can use target product, target sum to solve. And the target product is negative 12. The target sum is negative 4. The two numbers that will give me negative 12 and negative 4 are negative 6 and positive 2. And then remember what I said a while ago, and that, or remember what I said in the previous lesson, that if this is just a 1x squared, then all we have to do is set our factors to be x minus 6 and x plus 2. Now we set each of these equal to 0 and solve for x. In the first one, x is equal to 6, and in the second one, x is equal to negative 2. And we are done with today's lesson.